Welcome to next session of formal language and automata theory. So last class we have seen NFA with epsilon moves. So what is the mathematical definition of NFA with epsilon moves, and the string acceptance and E closure of Q, and the extended transition function delta cap. So in this video we have to discuss NFA with epsilon moves to NFA without epsilon moves. The example for this NFA with epsilon moves is, so this is one example. So Q naught initial state epsilon Q1 epsilon Q2, make this one is final state 2 1 and the Q naught 0. Take this one as an example of NFA with epsilon moves. So before converting NFA with epsilon moves to without epsilon moves, so we have to find what is the E closure of Q naught and E closure of Q1 and E closure of Q2. The E closure of Q naught equal to Q naught Q1 Q2. So E closure of Q1 equal to Q1 Q2. E closure of Q2 equal to Q2 only. These three are E closures. Now we have to draw the state table for this NFA with epsilon moves. It is same as NFA with NFA without epsilon moves table. So extra one is we are including epsilon. This is delta. So 0 is one input symbol, 1 is another input symbol, and 2 is another input symbol, and epsilon is another input symbol. The states are Q0 initial state, next Q1 and Q2. This is final state. So Q0 with 0, so Q0 only. Q0 with 1, 5. Q2 with 5, Q0 with 2, 5. Q0 with epsilon, so it will go to Q1. Same way Q0, Q1 with 0, 5. Q1 with 1, Q1 only. Q1 with 2, 5. Q1 with epsilon, Q2. Q2 with 0, 5. 1, 5. Q2 with 2, Q2. Q2 with epsilon, 5. This is the state table for NFA with epsilon moves. So when you convert NFA with epsilon moves to without epsilon moves, we have to know the extended transition function delta cap. The last class, the delta cap, we have discussed the delta cap of Q comma WA equal to E closure of delta cap of Q comma W, the remaining string A. This is delta cap formula. So first we have to remember this formula. Next, now we have to solve delta cap of Q naught comma epsilon. The delta cap of Q naught comma epsilon is equivalent to E closure of Q naught only. The E closure of Q naught is, already we have find this one, Q naught, Q1 and Q2. Once you find delta cap of Q naught comma epsilon, the next input is delta cap of Q naught comma 0. So assume that this is the 0. Before 0, assume epsilon delta cap of Q naught comma epsilon 0. So this is equivalent to E closure of delta cap of, use this formula, Q naught comma epsilon comma 0. So next step is E closure of delta of, so this is equivalent to Q naught, Q1, Q2 comma 0. Now this set is separated with this 0 by using union. So next one, E closure of delta of Q naught with 0 union delta of Q1 with 0 union delta of Q2 comma 0. Okay, so E closure of Q naught with 0, Q naught only, union Q1 with 0, 5, union Q2 with 0, 5. The final one is E closure of Q naught. The E closure of Q naught is Q naught, Q1 and Q2. So this is for Q naught comma 0. In the same way, we have to find delta cap of Q naught comma 1 and delta cap of Q naught comma 2, delta cap of Q1 comma 0, delta cap of Q1 comma 1 and delta cap of Q1 comma 2 and Q2 with all these three combinations, Q0, 1, 2 combinations. So finally the state table for all these combinations. So this is delta cap, so without epsilon moves, so that 0, 1, 2, so the states are Q naught initial state, Q1, so next Q2, Q naught with 0, already we find this one, Q naught with 0, Q naught Q1, Q2, Q naught Q1 and Q2, Q naught with 1, so Q1 and Q2, Q naught with 2, Q2 only. Next Q1 with 0, 5, Q1 with 1, Q1, Q2 and Q1 with 2, Q2 only. Next Q2 with 0, 5, Q2 with 1, 5, Q2 with 2, Q2 only. So this is the final state table for NFA without epsilon moves. Now we have to construct the state table already completed state table. Now we have to construct a state diagram for this NFA without epsilon. The states are, so the initial state Q0, next Q1, next Q2. This is the final state. So here, so we have to draw all these combinations. The combinations are 0, 1, and apply 0, Q1, apply 1, like previous table mapping only, 2, and 1, 2. So finally apply Q2 to Q0, 0, 1, and 2. So according to this theorem NFA with epsilon moves to without epsilon moves, so any final states in NFA with epsilon moves, so in our problem Qt is final state. The reachable states are Q0 and Q1, which means that the Q0 Q1 will go to Q2 final state by using epsilon, so that according to the theorem we have to make these Q1 and Q0 should be final states, so that here these two are final states, Q0 and Q1. So this is the conversion of NFA with epsilon moves to without epsilon moves. Thanks for watching the video. Subscribe channel.